Okay, so this is going to be pure mechanics, just how to do the problems. I'm not going to talk about concepts. We do that all the time in class. So equation of a line, 4, 2. So you should write x minus 4 plus 2. Change in x, 4 to 16 is 12. Change in y from 2 to negative 5. Looks like I'm going down 7. And there's our calculation. All right, write this in slope-intercept form. So it's just a question of doing your mechanics properly. Minus times a minus, a positive 20 over 3, and 7 is minus 21 over 3. So therefore, I can see my final answer is minus 5/3, x minus 1/3. Next, you can see it already. Name 3 coordinates. Well, minus 12 minus 18 pops out at me. And I know I'm changing my x's by 9. So that should be up 9 gets me to minus 1. That gets me to 8. Minus 18, and I'm going down 2. So minus 20, minus 22. We'll put an 8 in just to see if it works. And I made a mistake here already. Minus 12, minus 18. Yes. And I'm going up 9. So that's minus 3. So there's my careless error. And then that's why I'm doing this. So minus 3 plus 12. We can see the 9s cancel. Minus 2 minus 18 is that. So now I go up 9 again. And 6 plus 12 is 18. And 18 is a nice multiple of 9. All right, so there we go. I'm going to move the 8 minus 8 this way, which gets me 5x. I'm going to move the 15 that way, which gets me minus 11. So x equals minus 11/5. All right, let's move along. Okay, so I got some fractions. Let's get rid of them. Problem number 5. I'm going to multiply by 5 and 3, 15. All right, everything's going to get multiplied by 15. So that becomes minus 9x. That becomes minus 60. That becomes 35x. And that becomes minus 30. All right, I'm going to bring the minus 30 to this side. Add 30 to this. So that gives me minus 30. I'm going to add 9x to that side, which is 44x. And so that's minus 30 over 44, which is minus 15 over 22. That should be your x value. Okie dokie. So if I solve for y, I should get negative 5/7 x on this side, any constant. We don't care about that for perpendiculars. So the perpendicular is 7 over 5. It's actually right here to begin with. And for patterns, I'm trying to go through the Grand Canyon. So x minus g plus c. You can use capitals. Moving right along. Let's see, can I position this? I got to move the desk. Good enough, I can see it. Practice fractions. Minus 5 times, well, let's show minus 5 over 4 times minus 2 minus 7 gives us 10/4 minus 7, which is minus 28/4, which is minus 18/4, which can be reduced to minus 9/2. So there's your final answer. Solving f of x equals, well, f of x is this equation, minus 5x over 4 minus 7, and we're setting it equal to negative 5. So I'm going to bring the minus 7 over, I get positive 2. I'm going to multiply by 4, I get positive 8. I'm going to divide by negative 5 and move the negative into the numerator. So there's your final answer for that problem. Can we see these? Yes. So I'm going to take the 4 through to 16 and I'm going to cube it, 4 through to 16. 16 is 2, 2 cubed is 8, so that's what you do there. Square root of 28, square root of 4 times the square root of 7, so that's 2 root 7. I'm doing this because students come into my classes and they basically make the mistake of canceling the 6's, and 10 divided by 6 is not 4. Division cancels multiplication, so I want you to show this as 2 fractions. So 10/15 is 2/3 as a fraction, and there are 2 more x's in the numerator. Minus 25/15 is what? 5/3. So we got 5 over 3, and we've got 1x in the numerator, 5 in the denominator, we got 4 more. You do not have to put those fractions together. The concept I'm studying is the one I just talked about. All right, so to handle this one, you want to write this in terms of factors. So that's the square root of 11 times the square root of 4 times the square root of 11. Plus 2 times the square root of 11 times the square root of 3. That's how you want to visualize that. Square root of 4 is 2. Square root of 11 times the square root of 11 is 11. So that's 22. Square root of 11 times the square root of 11 is 11. Times 2 is 22 root 3. Okay, I could be making a mistake here. I'm going kind of fast. I see 10 more m's in the numerator. So I have m to the 10th, and I'm doing that 5 times, negative 5 times. So I would accept either m to the minus 50 or 1 over m to the 50th. And that's how you handle that. All right, so x minus 4. So this is something you'll study in the future in terms of slant asymptotes, but right now to get to 3, I need 7. All right, so that gets me the first two terms. It also gets me minus 28, and I got to get from minus 28 up to 11. So 28 and 11 is 39. And the way you check if this is right, I'm not asking you to write it there. At this stage of the game, most of you are probably writing it like so, and that's fine for right now. We will examine that more in the future. But just for point of reference, to make sure I've done that right, I'm going to drop a 4 in. Because right now, the 4 gets rid of that, leaving 39, which means that 4 over here, 16 plus 12 plus 11. 28 and 11 does turn out to be 39, so that's just my check that I didn't make a mistake. So solving for any number here, I would add 3. And I would multiply by 7, so I need that in parentheses, and I got to divide by 4. And that's the inverse of this calculation. How do I check it? Let's put a 7 in. 7's cancel. 4 minus 3 is 1. Let's put a 1 in here and see if it comes out as a 7. 4 times, well, 4 is cancel. It comes out as a 7. So that is correct. This answer over here is correct. All right, x plus 3 over what? 4. Here's your final answer. All right, moving to the front board. Okay, can I get 55 problems done in 40 minutes of faculty meeting that I'm not attending? Okay, so quadratic, which is all about squaring. All right, so the linear change here is 10. Right, from -1, but 10, I said I wouldn't do, I said I wouldn't do concepts, but I guess I still am. All right, so we've got x plus 1 squared plus 7. Drop a 9 in, I get 100. 100 plus 7 does not take me to 0, but if I subtract 7 from 7, that does. There's that function. The inverse of 5 to the x is log base 5. Of what? So we took care of that, x plus 2. So I've got to do subtract 2, and I've got to get an argument there. So that should be your inverse function. Let's check it with a number. Let's put a 1 in. 5 to the 3 is 125. So a 1 gets us 125. Let's see if a 125 gets us a 1. Yeah. What do you put on top of 5 to get 125? 3. 3 minus 2 is 1. So that is correct. This is a correct answer. All right, log base 8. I can see I need a cube root. Cube root of 8 is 2, and I got to do it to the 4th. And the way you can get that algebraically is to rewrite 8 as 2 to the x, and I'm raising that to the 3rd power. I want 8 is 2 to the 3. I'm raising that to the x power. And 16 is 2 to the 4. So therefore, 3x has to equal 4. 3x equals 4. When is that true? Check. All right, the only way that if this is factorable is if we have a minus minus, because I got to get a positive n term. Are there two numbers that multiply out to be 10 and add up to 11? Yeah, 10 and 1. All right, so you got to get some practice with that. I guess you can still see the board. Get it right. All right, so if I'm doing this, I'm starting at that x value. I'm doing plus minus the square root of, I have to move it units and divide by right. Yep. Get it right. Okay, so if this was 5, if this was 7, if this was a equals 2, it's got to be positive, yes? Then in graphing form, I could have written this as 2 times x minus 5 squared plus 7. I'm going to get some imaginary answers in this one, right? So I'm going to subtract 7. I'm going to divide by 2. I'm going to do a plus minus square root. And we've looked at this in class. Get it right. And check that out. Of course, I move that out here and write it as an imaginary. Last one. You should be able to binomial square much more easily now. Square the first term. Double that product, so minus 40x. Square that, you get 16 times minus 3 is minus 48. And then add 7. And if we do that, we should get minus 75x squared plus 120x. 48 take away, so 150 take away 6. So I believe that's 144, and a negative times a negative is positive, so 144 plus 7. I believe is 151. Okay? Did that quickly, could be wrong. I'm not checking it because I got another 30 problems to do. All righty, 34 problems to do. Let's erase the board and try for that before the meeting ends. Where is my cancellation? Bye-bye.